This time I'll call the meeting of the Public Energy Authority to order. At this time, I ask that we make a determination of quorum by the secretary to note. We have a couple members on the attending via teleconference. Could the members on the phone please just state your name so we can count you as being here?
Thank you, Mr. Chairman. Charlie Bird is here.
Mr. Bird.
Jeff Allen is here.
Thank you, Jeff. All right, well, at this time, I will move on to approval of the minutes. The minutes were distributed to the members previously. I'll ask if there were any corrections, notes, or concerns from any of the members. And seeing none, with seeing unanimous consent, we'll approve the minutes. Anybody object? Hearing none, the minutes will be approved. Now we'll move on to our first item on the agenda, which will be hearing an update on the status of the Pleasance Power Stations, which has been acquired by Almus Fuel Technologies. Here speaking to us today is Simon Hodson. Thank him for being here and welcome his insight from the background.
Who's doing it first?
Yeah, go there.
Should I do that?
Yeah.
Okay. Down. Okay. So, good morning. Thank you for inviting me to be here. Happy to give an update on our activities with regard to our newly acquired power plant in St. Mary's. We're delighted that we were able to do that. I wanted to point out several things that I think are important for the West Virginia Public Energy Authority. Number one, we are grateful for the cooperation and support that we received from the state and from the local community offices in helping us to save the power plant. When we became involved in the discussions, the plan and the notice had already been given by Energy Harbor and by ETEM, the acquiring group, to eliminate all 150 jobs that were there at the power plant. People were already looking for new jobs. They were already had their resumes out, and they were told that the plant was going to shut down as of June 1 was the first date that they were given. We knew that that was a concern for the state. We started to look at ways in which we might be able to help, and had several long negotiations. Had it not been for the wise actions of our congressional legislative body to pass the bill 609, right? Senate Bill 609. The position that was originally taken by Energy Harbor and by ETEM was that they were going to go forward. They weren't interested in selling the plant. They weren't interested in preserving the plant. They were going to shut the plant down. Because of the requirements of Senate Bill 609 that any group who was going to shut down a power plant had to demonstrate to the satisfaction of the people of West Virginia that shutting it down was in the best interest of the people and of the state, that they couldn't tear it down without doing that. And they saw that that was going to be a difficult task because the ability or the value of generating 1.3 gigawatts of power is an important asset to every community and certainly to the state of West Virginia. So because of that, we were able to enter into serious negotiations with them. We were able to conclude that, come to a reasonable amount, and we went ahead and purchased deposited that amount in escrow, complete that transaction, and I think it officially completed August 1, or August 3rd. I think August 3rd was the transition date of this year. More importantly, our provision, our requirements was not just the purchase price, but our requirements was that every employee kept their jobs, right? And that no one was reduced. We thought that was an important thing because it's not just power generating capability, it's the people that can run the facility for the power generating capability that's important. And 150 people and their jobs is important, but we have since then, the county commissioner, Jay Powell and others have introduced us to more than 1,000 individuals that have said they earn a significant part of their income by that power plant and the operation of that power plant in that area. So it's 1,000 families. It's the livelihood of 1,000 families, and we think we're very pleased that we're able to do that. It cost us some money. We were required to pay all those salaries during that period of time. We've done that, kept the people, and we're delighted to have them. They're good, well-trained people, and they can do a great job of running that power plant. The second thing that's important is that we've been asked by a lot of people, so what's your plan? Why are you doing this? What's your plan? And we believe in the green agenda. We 100% believe in the green agenda. What does that mean? We believe that anything we can do as individuals or as a corporation that helps to support a clean environment is the right thing to do. Absolutely, we are committed to that. And we believe that the generation of electricity from hydrogen is probably one of the smartest things that we can do as a society. But it can't raise the cost of electricity beyond the ability of everyone to pay. It can't raise the cost of operations so that we have huge amounts of waste or that we destroy ourselves in another aspect. So we have created a technology that works. It will not raise the cost of electricity. So one of the things that we wanted to report to you today is our plan to convert the Pleasance Power Station to hydrogen will preserve the asset that's there, preserve the jobs that's there, and most importantly, will not increase the cost of electricity to operate the power plant and for the users of that power. We think it's an important thing. The next thing to report is we're going to use coal as our preferred hydrocarbon to generate that electricity. And there have been inquiries that we've received since the governor's announcement last week or so, where he talked about the fact that we kept the power plant open and preserved the jobs and the generating capacity. So we've received calls from the New York Times, from CBS, from the Associated Press, from many people saying, what are you doing? What's your idea? And people who had looked a little bit said, wait, but you're still burning coal. And they perceive the burning of coal as a bad thing with regard to the environment. We said, we understand that. We're actually not planning on burning coal. Instead, what we're planning on doing is taking the coal and ripping it apart into its component, hydrogen and carbon. But there's no combustion of coal that will take place. But we will be using coal as our feed material, using coal as our fuel source, and then we're taking it and separating it into the hydrogen that will be used to power the power plant and the carbon that we can then use in other industries. Before I talk about that, and this is the process that we use, those funny little arrows, and I'll talk about those in just a moment, but I want to talk about the overall concept because it's important. So right now, what people don't realize, and I helped our friends at the New York Times understand this the other day, is I asked them a question. I said, when you go to a coal-fired power plant, what percentage of the energy of an existing coal-fired power plant is hydrogen, is green? What percent of the energy that goes into making that electricity currently is green? And they said, well, it's none, it's coal. And I said, no, you're quite wrong. 35% of the energy that from a ton of coal that goes into a power plant, the energy, 35% of that energy is hydrogen. So already every existing coal-fired power plant is running on 35% hydrogen today. I think that's an important thing for us to just stop and recognize as we move towards a cleaner, greener method of making electricity with our ultimate goal of being 100% green and clean, right? It's important to recognize that 35% of the power or the energy that goes into making our current electricity is already hydrogen if you're burning coal. If you're burning natural gas, that number's more like 55% is hydrogen energy. Because hydrogen is so powerful from an atomic level or a molecular level, it contributes a huge amount of the energy. The carbon does not. The carbon is a much lower energy material and really shouldn't be used as an energy source. There's much better uses of carbon. So our idea is this process shows that we take input material and we convert it, and I haven't got pointers, but we convert it from a coal feed or other hydrocarbon feed. At the Pleasants Power Station, it will be coal, and we're splitting it into hydrogen gas that then fuels the power plant. And the carbon that comes out, because of our ultra high temperatures of processing, about 3,000 degrees Celsius, is going to allow that carbon to go to its most stable natural state. And that's called graphene structure or graphite. And the reason that's important is since 2008, there have been more patents filed by more scientists, laboratories, and companies on the potential application of graphene than any other material in the history of the world. From making furniture, to making fibers, to making roads, to making bridges, redoing our construction surfaces with material that will be stable and doesn't rust, doesn't corrode for 3,000 years, right? This is a marvelous material that we've had all around us for centuries, and we've never known how to produce it in large quantities. Well, if we can grasp that concept, then the generation of energy can yield as a significant byproduct a material that can then be used in a wide variety of applications to give us a much more stable, much more green, better performance economy. From car bodies and car parts made of graphene or graphite that would weigh a third of the weight or less than steel, right? Or just incorporating the graphene into steel to improve its properties by 20 to 50%. These are things already recognized by the scientific community. It's just that they didn't have a source. Well, we believe that the Pleasants Power Station is going to show that we can not only generate electricity, but we can now generate a source of another material, another industrial material that can give rise to a complete change of society, of the many, many things that we make in society. To do that, we're actually going to be purchasing more coal. So instead of purchasing the same amount of coal, because we need more graphene in the environment, we're going to be purchasing more coal in order to get enough hydrogen so that we can go to 100% hydrogen, right? So if you can see easily, if we're only getting 35, or if we're already getting 35% of the energy from hydrogen in our existing amount of coal, how much more coal are we going to need to get 100%? Easy arithmetic, right? 3 times. So we will be purchasing almost 3 times as much coal, right? Not quite 2.5, because we don't have to deal with the moisture in the coal. So it'll be about 2.5 times the amount of coal in order to give that same amount of hydrogen. But that's going to give us the ability at Pleasants to produce 6 million tons of high quality graphite a year. Now, what's graphite immediately good for? Well, power generation and power transmission, I think, are going to be inextricably combined. So if you look at the best thing to use for power transmission as we struggle with better, more stable transmission lines for electricity, graphite is a far better material to use than is aluminum wrapped around a steel core, which has never made much sense, and it's over 150 years old. Let's reinvent that, and let's use graphite to do a much better job where you don't have metals that rust and corrode and you get line breakage and outages and so forth. Graphite would be stable for thousands of years, and it's completely benign to the environment, and most importantly, doesn't corrode, doesn't rust, and has a much better power generation, or excuse me, power transmission characteristic than does any metal, including copper, in existence. So we're going to be doing those things at Pleasants. The reason that's important is we anticipate at least 100 more jobs being created by this retrofit. So we've preserved 150 jobs that are there, but we believe that in handling 6 million tons of graphite, it's a new industry. So we're in the process of acquiring an additional 30 acres next to the power plant that will be used to build these reformers, which is what we've got behind us. And let's see, these are the individual reformers, and one's called an FMS system, which is the system we use to dry the coal. It just takes out the moisture because you can't have any moisture, otherwise you create CO2 emissions. So we take out all the moisture, and then we go into what we call our OQR system, which is a high pulse jet power system. We generate the electricity, and then most of the hardware you see there is to collect the graphite particles. And the tube that goes out, as you see in this diagram, that's the exhaust out, where it says exhaust out at the top. That's just for hydrogen. So that's running at 95% hydrogen and a little bit of nitrogen, and that goes directly into the power plant. There's no need to cool it or to compress it for its transportation, and therefore you save thousands and thousands of dollars per ton because you're not having to compress it and deal with all the extra hazardous potential of compressing hydrogen or cooling the hydrogen. So this is the unit that we are planning to build 36 of those modules. 36 of those modules will give us 120% of the hydrogen capacity needed to run the power plant. What that means is we have robust, sustainable production. Each module will be separately run so that we believe we can have full, sustained 100% supply of fuel, right? More importantly, we've got an excess 20% capacity, so if someone said, I want to run hydrogen trucks, I want to run hydrogen trains, they can come and fuel right there while they're dropping loads off, or where they're dropping trains off. They can refuel their system right there on site, come in, drop their load, and go on and be pure hydrogen. So we think this is an example of the new hydrogen economy. It will be the first power plant in the world that's been converted to hydrogen. It will be the largest power plant that's even in the planning phase for hydrogen. The largest right now is 100 megawatts by NextEra. They're not going to be ready to go till 2027, and they'll only be at 20% capacity of hydrogen. I think that's a funny number because when you're spending money to go to 20%, I just say burn coal, you're already at 35, right? But they're going to spend $2 billion building a 100 megawatt power plant. But I'm not saying anything negative about NextEra. I'm just saying that right now, this is going to be a leading piece. This is a leading piece worldwide. There is no other company in the world that is planning to do something like this, and we believe that we'll be online within the next 2 years. We have been quoted that if we can get the permits and the engineering completed quickly, that there's only an 8-month time needed to do the conversion. I'm not sure that in our post-COVID era of getting equipment that we won't be delayed a little bit, but we're certainly trying to get it done in the next year. One thing that's important to note is you say, well, why are you acquiring 30 acres of land? That's a lot of land next to the power plant. Well, one of the things that we need to put in is an oxygen generating unit. So the thing that allows us to generate the ultra high temperatures is we remove the nitrogen from the air so that we're running on pure oxygen or almost pure oxygen in the reforming step. That's important because it allows us to get high temperatures in our reformer. but you should know that this will be the third largest oxygen generating plant in the world, right? So that's in process of engineering right now. They're going to build that, and we've got 2 others on the drawing board. And when we went to the people who supply these, they said, how much oxygen do you need again? And we said, well, we need 400 tons an hour of oxygen. They said, there's only 2 larger plants in the world. And we said, well, is that hard to build? They said, no, actually, it's pretty easy to build. No one usually asks for that. So this is going to be a wonderful facility, clean facility that we're going to use oxygen to run our facility. But that's going to take up probably 50% of the acreage that's there. That's going to be in an oxygen plant. And of course, we need all the jobs related to running that plant as well. So that's my brief overview and update of where we are. We have engineering has begun on site. The vendors have been contacted, and we are trying to get the facility moving forward fast enough that within the next 6 months we can have one of those operating modules on site. So we have to have 36, but we want to have one operating on site for 2 reasons. One, we want to show people that you can do it. We want to show people on a full commercial scale what they're going to see, and this will act as a training center then for all the additional people that we'll be hiring. We'll flare the hydrogen. That's our plan, is to flare the hydrogen. So we'll turn the hydrogen back into water. And so if there's a little more rainfall in the county over the next year, we'll know where it comes from, because that's what happens when you burn hydrogen. It goes to water vapor. But more importantly, we'll be able to start the graphite supply. So we have 2 steel companies that have asked for the graphite that's going to come out of this facility, and we want to give them initial quantities soon. So we're hoping to do that within the next 6 months. We hope to have actually an operating facility on site. So that's going to be a challenge for us, but we're working hard to make that happen.
I want to make sure I understood you said you're purchasing 2.5 to 3 times more coal. Is that as it combined to when the Pleasants Power Station was burning coal at full power?
Yes. So let me be specific. Their historical purchase of coal, depending on the quality, right, moisture content and so forth, has been around 3.5 million tons a year. That's allowed them to operate at about 76% total uptime, right? So if they were at 100% total uptime, that number would be increased by 25%. So say 4.25, right? Million tons, call it 4 million tons for easy math. We would anticipate that we'll be purchasing about 10 million tons.
Is that metallurgical?
No, this is actually, I shouldn't say this in a public forum, but this is actually, if you look at the grade of the coal, it's pretty poor quality coal. It's coal that can only be burned in certain environments that can take it, so that the sulfur content is abnormally high. But fortunately, the Pleasants Power Station, the people designed and built it, designed it for the potential advent of high sulfur. So the sulfur in this coal is over 6% sulfur, and we're able to take all of that out, turn it into gypsum, put it into the construction materials market at a profit to the power plant. And they've got that facility in place to do that. When we're converting it over into hydrogen, we'll continue to do that, but in this case, we upgrade the sulfur to a higher value. Instead of selling it for about $35 a ton, we're going to sell it for about $300 a ton because it's better quality material. So, but the direct answer to your question is yes. Instead of the 3.5 to 4 million, we'll be between 8 and 10 million tons of coal a year.
So I enjoyed seeing your facility out in Santa Barbara. I don't know if seeing that whole long wall of patents, if any of those were for the graphite that you mentioned, but
4.
4 of those were.
We've got 500 patents on the wall, 4 related to the graphite.
Simon, we appreciate your investment in the state and all of your fellow investors. including those here in West Virginia. We appreciate the investment.
Thank you. I'd like to make a comment back to the state of West Virginia if I could. I'm a newcomer. You can tell I don't even speak the language of West Virginia yet. I'm working on it, but I don't speak the language quite yet. We have been approached by people in surrounding states that obviously have the supply of coal, and they also have these same challenges. How do we meet the environmental requirements? How do we meet the emissions requirements? The new proposed regulations by the EPA that all fossil fuel burning plants need to control 90%, right, of their CO2 emissions, which is a requirement that you cannot, I don't believe you can meet without greatly increasing the cost to the taxpayer for electricity. And I look at those things and I think, how's it going to be done? But these surrounding states have also indicated that they have a problem. One of the reasons we're in West Virginia is that this state understands coal. They understand the environment. They love their environment. They love their parks. They're everywhere and they're beautiful. But they're practical people. And so as we've come here and we've presented our ideas, Chris, we have been able to meet with very, very intelligent, capable, informed administrative, regulatory staff, both elected and appointed, that understood the problems and they understood potential solutions that would work. And the reason that we've been able to move forward so quickly here, and it's been so slow in other places, is that your understanding of coal, your understanding of the challenges of coal and coal emissions is at the best we've seen at any level, statewide or nationally, at the federal level. And so we are encouraged because it's so much easier for us when we present the solution. The people involved know that it's a real solution that will work in the best interest of energy generation and to the ratepayer or to the consumer of electricity. And so we're delighted to be here because it makes our job easier to show some great technology. We really view this as a partnership. So we appreciate it very much. Mr. Busher, anything else?
Some, just to clarify with everybody, the governor made his announcement last week, but some folks watching may not be aware. Would you explain the current state of electrical generation at Pleasant as we see it today?
Right. Well, right now it's running the same way it has been for the last many years. So it's running on the same coal feedstock. It's running the same 2 furnaces. We've gone through a retrofit, a simple rebuilding and maintenance program. So it's running well, right? It's running well. The plan is to build out all of this conversion process. That is, the generation of graphite and the generation of hydrogen will all be done separately on the land next door, and we will not interrupt the power generation capability of that plant. The changeover that will occur is a changeover that we have been told by Zeeco, who is our partner on the furnaces, will take about 3 to 5 weeks per furnace. So we'll do one changeover first and then the other changeover second. So we shouldn't have interruption of power supply for more than normal maintenance downtime, but that changeover will occur 50% and then the second 50%, and we anticipate that will be in about a year to a year and a half. If we can get this first unit operating quicker, that makes our ability to train people quicker, better, so we might be able to do that faster. You know what's wonderful about this particular technology? It's what I call it's a bipartisan technology. It is not a Republican technology or a Democrat technology. It's not conservative, it's not liberal. It's something that makes sense for everybody. We all want a green environment. None of us want to see our electrical costs go up. We all want to use our natural resources in the very best way that they can be used. And we all want the future to be better, easier, more sustainable. We think that this is a contributor to all of that. So my answer is, to clarify, we have not switched to hydrogen. we're still burning on coal because we have to go through this process. The investment required from us will be much more than $800 million, which was an initial number. But we're between $800 million and $1 billion of investment to make this all happen. But you're creating a new industry. You're not just upgrading a power plant, you're creating a new industry for graphite.
You're generating electricity,
We are generating
transmitting
electricity
it to PJM.
today.
Yeah.
We are live on PJM today.
And my understanding is, there was a period there where it was mothballed technically, which meant everybody was there still working. It stopped generating electricity.
The plant was shut down.
Yeah,
The
and
plant was shut down.
yeah, it was not generating electricity. It is today, and that's the first time that we've ever seen that in the country.
You know, when they shut the plant down,
We had several conversations. We didn't want them to shut the plant down. And they said, no, we're shutting the plant down June 1. We watched carefully with drone footage as the coal pile went down, 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 down. And there was not one 2-inch piece of coal on the ground. They cleaned everything out. It looked like the Grinch that stole Christmas. They went in and took everything to the last bulb on the tree. And they shut the plant down. And we met with the employees and said, look, we're going to do our best to keep this up and running. We are for sure going to pay your salaries. So while we've got this downtime, while you shut the plant down, let's go clean it up. Let's go do all the maintenance that's required to make sure that when we're going to start this back up again, it's ready to go. So they shut it down and stopped generating power, gave notice to PJM, gave notice to FERC. We applied to FERC. We had to go through the approval process. We then talked to PJM. PJM gave us the approval to start up, and we actually started on the 29th of September, I believe that was the date, which was about 5 or 6 hours before the governor got us online and was talking to the people at the site. I want to point out something just because I think it's interesting. The 29th of September is notable because it was a super blue moon, right? A super blue moon has two characteristics. One, it's a second full moon in a month, right, which is kind of fun. But more importantly, the super blue moon occurs very, very, very rarely. It's a time when the moon's orbit around the Earth, which is not spherical, but it's elliptical, it goes through the apogee. So it's the closest point that the moon is to the Earth at any given time. And those two things occur very, very, very rarely. And I think what punctuated that is, to my knowledge, there has never been a coal-fired power plant that was shut down, mothballed, right, turned off, that started up again. We're told this is the first time it's ever happened. And some people are concerned about that. They're saying, no, it's good to shut down coal-fired power plants. And we say, it's never good to shut down power generating capability to a society that so desperately needs it. 50% of the world's population lives in energy poverty. They don't have lights to turn on to go to the bathroom in the middle of the night. They don't have electricity to run heaters. And many people die. They certainly suffer, but many people die because they don't have access to things that you make possible for the citizens of West Virginia. And so we think it's irresponsible to just shut down power plants of any kind because we don't like their fuel source. Instead, let's fix the problem, which is the way we use the resource. Let's not shut down power generation capability and celebrate that.
Thank you. Mr. Allen, Mr. Byrd, do either of you have questions for Mr. Allison?
Mr. Chairman, Charlie Byrd here. I know questions, but I apologize I couldn't be there to see that presentation. And it appears to be certainly a win for the state of West Virginia, a win for the people of West Virginia, a win for labor, and certainly a win for environment. Thank you.
Thank you. Well,
Mr. Chair,
Mr. Allen?
Mr. Chairman, I wanted to thank you guys. I'm sorry I wasn't able to be there to see the presentation. It sounds wonderful. I'm very excited about the technology and it looks like good things are happening in the state of West Virginia. Thank you.
Well, thank you. Well, Mr. Allison, thank you very much. I really appreciate you being here to give us this overview.
Thank you. Happy to
Public
be
update.
Appreciate it.
Thank you very much. At this time, we'll move on to the next item on the agenda, which is consideration of the agency-approved emergency rule for Senate Bill 609. I will welcome Graham Platts, attorney for the department, to fill us in on the update, and then we'll entertain motions.
Thank you, Mr. Chairman, and I've gotten word that Harold Ward is available if you'd like to add him or if you'd like me to continue. Sure.
Hi Harold, this is Megan. We have you, you can hear everybody, okay, right?
Yeah, we're good.
All right, thank you for joining.
Secretary Ward, we just moved on to the consideration of the agency-approved emergency rule. I'm turning it over to our counsel, Graham Platts.
Thank you, Mr. Chairman, members of the authority. Today, I wanted to review the agency-approved rule for Senate Bill 609. The authority commenced a public comment period on June 23rd, 2023, and after 30 days, that comment period expired. The authority has drafted substantive responses to all of those comments, and those will be filed with the authority's filing of the agency-approved rule. And so I'll walk through the changes that were adopted in light of those comments now. On page 2 of the rule, subsection 3.1.1, amended references to code that were incomplete to add additional sections related to the PSC's jurisdiction over power plants. Section 4.4.3 was amended to adjust and that is on page 4 of the rule, I apologize. Section 4.4.3 was amended to adjust the timeline that petitioners have to file a petition to 180 days, just to extend that time frame for petitioners. That was one of the requests submitted in the comments. And then additionally, the authority included a provision that allowed petitioners to request even more additional time upon good cause shown. At the bottom of page 4, the next change, section 5.1.1.a, amended and corrected definitions used within the rule to match more completely. That was just a technical change. The next amendment was section 6.3 on page 7. There, notice requirements were amended to include service on the Director of the Public Energy Authority and the Director of the Office of Energy. That's 6.3.5 and 6.3.6 respectively. The next change, 6.4, also comes at the bottom of page 7. That is another technical change that corrected a typographical error and replaces section 8.3 with the correct section 6.3 reference in that subsection. Section 7.6 on page 8 amended the public comment period to allow for petitioners to respond to any comments received by the authority if they so choose. Additionally, on page 8, section 8.1.3, the petitioner is also entitled to now respond to any additional information that is requested and received by the authority. And so those changes were made to allow petitioners the chance to respond to any and all information submitted and considered by the authority. The next change, section 8.2.2, it comes in page 8 and page 9, and that section was actually removed from the agency-approved rule after receiving a comment questioning the authority's jurisdiction. Section 8.3 on page 9 is the final change adopted by the authority, and that change clarifies the timeline for resubmitting a petition if the authority denied that petition. And so under the agency-approved version of the rule, a petitioner would have 90 days to resubmit a petition to address the infirmities identified by the authority without beginning the rule process from step one, providing notice and going through that process. They could directly submit another petition within that 90 days. However, if 90 days expire from the authority's denial of a petition, petitioners must restart the rule process from the beginning, including all notice provisions. Mr. Chairman, those are the changes adopted in the agency-approved rule.
Thank you, Mr. Platt. Are there any questions from members?
Mr. Platts? Seeing none, I will entertain a motion to final file the emergency rule for, it's actually 53 CSR 5. Final file that with the Secretary of State's office with the changes that have been provided to the members, and also the responses to all the public comments.
So moved as submitted, Chairman.
Do we have a second?
Second.
All in favor, say aye.
Aye.
All opposed, nay. No. The ayes have it. The rule is final approved and will be submitted. Thank you all very much. We will now move on to announcements. Any announcements? Actually, this is my lapse. I hadn't thought about the next meeting day. I'll get with our staff and the members, figure out the next time we're going to meet, and then we'll announce it, distribute it to everybody. Any remarks by members? Seeing none, I'll entertain a motion to adjourn.
So moved.
A second.
Second.
All in favor, aye.
Aye.
All opposed, nay. The ayes have it. We're adjourned. Thank you all very much. And thank you to all the members participating virtually. I know, being a special meeting was tough to get everybody